Hi students, my name is Ishan Akbar from Civil Engineering Excellence Academy. Today I am going to discuss third part of the basics of civil engineering, or basic knowledge of civil engineering part 3. Before starting my video, if you have not subscribed my channel, kindly subscribe my channel and refer it to other civil engineering students and professionals. Thank you very much. The second part in last video, in the part third of the basics of civil engineering, I discussed about the basic properties or basics of cement. Today I am going to discuss basics of concrete. This video will be in two parts. This video number 3, basics number, sorry, 4, and basic number 5. So the first point in concrete basics is the grade of concrete mix. Whenever we say the grade of concrete mix, then what do we mean by this? We mean that the proportions of cement, sand, and aggregates. Sorry. In any mix, you have to decide about the proportion of cement, proportion of sand, and proportion of aggregate according to the strength of concrete. The second question is usage of PCC and RCC. PCC means Portland cement concrete. In this concrete, reinforcement is not used. In RCC, reinforcement is used. This is reinforced cement concrete. The plain cement concrete is mostly used where compressive forces act purely. It means that we will only use or we will only prefer Portland cement concrete where only we encounter or our structure will be under compressive forces. The clear note here is no tension. It means that if any structure is bearing tension, then you cannot use PCC in that structure. The next one is reinforced cement concrete is used where compression and tension acts simultaneously. It means that if your structure or structure under consideration faces compression forces and tension forces as well, then we will have to use reinforced cement concrete (RCC). So PCC is pure for compressive forces and RCC is purely for compression and tension forces. This may also resist flexural forces. The third point is comparison of steel and concrete strengths. Simply, maximum number of people or number of civil engineers know that steel is strong in carrying tensile forces. Therefore, RCC is used as for compression and tension due to involvement of reinforcement. Tension has become property of concrete. Due to involvement of steel, the tension or tensile forces carrying capacity of concrete has increased. So simply we can say that concrete is strong in carrying compressive forces and weak in carrying tensile forces. The next one is steel is strong in tensile forces while it is weak in compressive forces. Fourth point in concrete is failure mechanism. Failure mechanism in concrete and steel is different because concrete is a brittle material, so it will fail by brittle failure. Concrete mostly show brittle failure, and this brittle failure is always without warning. And in steel, steel is a ductile material, so it gives ductile failure, giving warning as a building safety. So if we use steel in building construction, then it means that we can save our building to some extent and it will warn us before failure. The fifth point is why only steel is preferred to be added in concrete for reinforcement. That is simply a single point agenda that steel is only preferred. Why we cannot use copper or other materials in concrete for reinforcement? The simple answer is this: the thermal expansion coefficient of both materials mean steel and concrete. These both have nearly same coefficient of thermal expansion. That thermal expansion coefficient is for both material 12 cross 10 raised to power minus 6 per degree centigrade. It means that if you increase 1 degree centigrade temperature, then your materials, both the materials will expand with a value of 12 cross 10 raised to power minus 6. Sometimes someone may ask the order of expansion, that will be 10 raised to power minus 6. Minimum number of longitudinal bars in columns. So if we have columns, then we must know the minimum requirement of number of bars in longitudinal in columns as a longitudinal reinforcement. So if we have a circular column, then the minimum number of bars must be 6. It means that if this is a column, then you will have to use minimum 6 number of bars as longitudinal reinforcement in this pattern. But if you have a square column, then there will be minimum number of 4 longitudinal bars at these positions. If they are 4, if they are 6, they may be used in this position. If they are 8, they may be used like this. They may be more than 8, and their arrangement will be on the boundary, near to the boundary, leaving the cover. So in case of a square column, minimum number of bars required is 4. For a square column, minimum number of bars are 4. Like this. Here, one bar will be placed here, second here, third here, and fourth one here. The seventh is the maximum height from which concrete is thrown at site. The concrete is thrown at site at a height which is less than 1 meter. It means that concrete should be thrown, there should be must. Concrete must be thrown at a height of less than 1 meter at site, less than 1 meter. So if this is your construction site and here is the concrete supply source, then you will throw this concrete from this pipe. The distance between this pipe and this side must be less than 1 inch. From the opening mouth of the pipe to the site where the concrete is to be placed, this distance should be less than 1 meter. You will not place or throw concrete greater than 1 meter height. What will happen if you throw this concrete at a distance of more than 1 meter? This honeycombing will occur. The honeycombing basically is the separation of contents. Separation of contents mean coarse aggregates will be separated from concrete if you throw from more height than 1 meter. The eighth property of concrete is what type of sand is considered good for concrete mix. The sand which has a moisture content of less than 5%. If a sand you are going to use it in concrete, then you will check its moisture content in the laboratory, and if this moisture content is less than 5%, then you will consider it as a good sand for concrete preparation at the site or at any construction project. Number 9 is, what is DPC? Its function and its requirements. DPC is simply called as damp proof course. What is its function? Its function is to stop upward movement of moisture from foundation or from nearby soil to superstructure. And its requirement is the minimum thickness of the DPC or damp proof course should be 2.5 centimeters or 1 inch. It may be of 2 inches. Mostly it is used as 2 inches, but its minimum thickness required is 1 inch. You should not use DPC less than 1 inch. The 10th point is height to which concrete can be lifted with the help of pump. That simply is 50 meters. You can lift a design mixed concrete with the help of pumps at a maximum height of 50 meter. You cannot lift concrete more than 50-meter height with the help of pumps. The 11th point is the curing period of PCC and RCC. That is a well-known agenda or well-known point that the curing should be done for nearly 28 days. Why this time for curing? Why it should be done for 28 days? Why? Because concrete gains 99% of its total strength in first 28 days. So, and at any construction site, it should be cured, or RCC or PCC structure should be cured for 28 days, but mostly 25 days curing is used at site. So that's 12th point for this is density of PCC, Portland cement concrete is 2400 kg per meter cube and 150 lb per feet cube. In SI units, this is 2400 kg per meter cube. It means that in 1 meter cube of concrete, you will get 2400 kgs of concrete. In 1 foot cube of concrete, you will get 150 lbs of concrete. So this is density, not the unit weight. The density of reinforced cement concrete is simply 2500 kgs, 100 kg per meter cube more than PCC. This is 2500 kg per meter cube or 155 pounds per foot cube. The unit weight of Portland cement concrete is simply 24 kilonewton per meter cube, or for RCC, the unit weight of concrete is simply 25 kilonewton per meter cube. Thank you very much.